Hello everyone. On this video we will be looking at how to solve radical equations. Okay, so first off what I want you to do is remember that if you have the square root of x, if you square a square root, the exponent and the index, which in this case when there's no index here, it's a 2, those two cancel each other out and you end up with whatever your radicand is. In this case, it's x. All right. So in other words, let's say another example. If you have the square root of 3x plus 7 or something like that. If you square it, the exponent and the square root cancel each other out, and you end up with just your radicand, which in this case is 3x plus 7. All right, so we're going to use that to solve radical equations. Okay, so let's say, for example, we want to solve for x for the equation square root of 8x minus 23 equals x minus 2. All right, so most importantly, your very first step when solving radical equations is to make sure that the radical or the root function is isolated to one side. The radical term is isolated on one side, then square both sides. Okay, so that's what you want to do. All right, so in this case, the square root of 8x minus 23 is the only term on the left-hand side of the equal sign. Okay, so it's already isolated, so we don't have to do anything here. Okay, so if you have the square root of 8x minus 23 equals x minus 2, and you have our isolated radical, we go ahead and square both sides. Okay, so once again, our exponent and square root cancel each other out. So we end up with just the radicand, that is 8x minus 23, and x minus 2 squared, instead of working that out in the middle of the problem, x minus 2 squared, remember that's just x minus 2 times x minus 2. So if you use the FOIL method, you end up with x squared minus 4x plus 4. So x minus 2 squared is x squared minus 4x plus 4. All right, so now we want to get everything to one side so we can solve this. So if we subtract 8x and subtract 8x under the like term, 8x minus 8x is 0. If we add 23 and we add 23 to both sides, negative 23 plus 23 is 0. So we get x squared. Negative 4x minus 8x is minus 12x. 4 plus, well, positive 4 plus 23 is plus 27. Uh-oh, I was about to write there, plus 27. And that would be 0 equals that, but I always like to have my terms on the left side. That's just my own personal quirk. So you have x squared minus 12x plus 27 equals 0. And if you write it as 0 equals x squared minus 12x plus 27, that's fine too. Like I said, this is my own little personal quirk where I like my variables on the left side. I'm just odd like that. Okay, so we go ahead and factor once we get everything to one side. Okay, so x squared minus 12x plus 27 factors to become x minus 9, x minus 3 equals 0. Okay, so we know that this means that x minus 9 equals 0 or x minus 3 equals 0. So if we solve this one, we know that x is equal to 9 or x is equal to 3. Okay, now one thing we have to do when we're solving radical equations, we have to plug in our answers into the original equation, because they won't always come out to be true. Even though it's a solution, it won't always come out to be true. Okay, so plug in both values to make sure they satisfy the equation. Okay, so in this case, both are solutions. Okay, so if you plug in 8 times 9, plug in x equals 9. 8 times 9 minus 23 equals 9 minus 2, you'd get correct answer. Same thing with x equals 3. If you plug that into the original equation, you get a true statement. Okay, so of course, we'll let you do that on your own. All right. Let me move that up a little. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so say for this example, and I want you to try this one on your own first. Again, we want to solve for x, and we have the square root of 4x minus 12 plus 3 equals x. Now remember, you're going to use the exact same steps from the previous example. All right, so I'm assuming you've pressed pause and you've already worked this one out. So let's go ahead and verify your answer. Okay, now remember the first step from the previous example is that you want to isolate your radicand, or your radical rather. Isolate your radical or root function, then square both sides. Okay, now if you notice here, our root function is not isolated. It's not the only term on that side. You have that plus 3. So whenever you have a root function and you have a plus a number or plus something, you have to get rid of it so that root function is by itself. Okay, so if we subtract 3 from both sides, we will actually end up with square root of 4x minus 12 equals x minus 3, because we just subtract 3 here, subtract 3 on this side, and that's what we end up with. All right, so once we isolate it, then we square both sides. So we square this side, and we square that side. Okay, now on the left side, the square and the exponent and the square root cancel each other out. So we have 4x minus 12. X minus 3, again using the FOIL method, we have x minus 3 squared. Remember, that's just x minus 3 times x minus 3. And using the FOIL method, we have x squared minus 6x plus 9. Let me see if I can clear this up a little. A little bit better. Okay, so x minus 3 squared is x squared minus 6x plus 9. All right, so just like before, we want to move everything to one side. So we're going to subtract 4x minus 4x. Those two cancel out. We have minus 12, so that means we add 12 to both sides. Those two cancel out. So we have x squared, negative 6x minus 4x is negative 10x. Positive 9 plus 12 is positive 21. Remember, you can have 0 equals that if you want to. I just make mine look like that. All right, so now we go ahead and factor our left side. We have x minus 7 times x minus 3 is equal to 0. So that means that x minus 7 can equal 0, or x minus 3 can equal 0, or x equals 7, and x equals 3. Okay, and again, once we plug both of those values into our original equation, we'll see that both of them are true. Plugging in both values shows both are solutions. All right. So if you are still writing, please feel free to press pause, but we're going to go ahead and move on to our next example. All right, so again, I want you to try this one on your own. What if you wanted to solve square root of x plus 12 equals x? Let me make that a little clear. All right, so go ahead and pause it and solve this one on your own. All right, so assuming you've pressed pause and you've already worked this one out, let's go ahead and verify your answers. Okay, so our radical is already isolated, so we don't have to do anything else with that one. So you have the square root of x plus 12 equals x. So since our radical is by itself, we're going to go ahead and square both sides. Our exponent and our square root cancel each other out, so we're left with x plus 12 equals x squared. Okay, so we're just going to get everything to one side, so we're going to subtract x from both sides, and we're going to subtract 12 from both sides, so we end up with x squared minus x minus 12 equals 0. Okay, so if we go ahead and factor our x squared minus x minus 12, we get x plus 3. Let me clean that up a little bit. X plus 3 times x minus 4 equals 0. So of course that means that our x plus 3 can equal 0, or our x minus 4 can equal 0. Or x can equal negative 3, or x can equal 4. Okay, so if you plug that in for your answer on an exam, you would be incorrect. And I'll tell you why. If you plug both of those in, only one of them will actually work. So when x equals negative 3, you have the square root, negative 3 plus 12, equals negative 3. So you have the negative 3 plus 12 is negative positive 9. So you have the square root of 9 equals negative 3. So square root of 9 is equal to 3, because remember, when you're working with radical equations, you're only looking at the square root from a positive value. You're not doing the positive and negative. So you have the square root of 9 is equal to 3. It is negative 3, which is false. All right. So since that's false, you can't use negative 3. So that means x equals 4 is the only solution. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and go to our last example. Where you have questions involving two radicals. Okay. Now we have two radicals. You do the exact same steps, but you do them twice. All right, so for example, what if you wanted to solve for x? And you have the square root of negative 2x plus 4 plus the square root of 2x plus 5 equals 3. All right, now just to see how well you can do this on your own, go ahead and give it a try. Remember, you want to use the same steps as before, but you're going to end up doing them twice. So go ahead and just give it a try. Excuse me. All right, so I'm assuming you've pressed pause and gave this one a shot. So let's verify your answer. All right, so remember, first thing you want to do, but since you have two radicals, you just want to isolate one of the radicals. Then square both sides. All right, so let's say we isolate the square root of negative 2x plus 4. You can isolate the square root of 2x plus 5 if you want. I'm just picking this randomly. Okay, so we have the square root of negative 2x plus 4. So if we subtract the square root of negative 2x plus 5 to both sides, that will equal 3 minus the square root of 2x plus 5. So all we did was subtract that from both sides. Okay, and just like before, once you isolate one, you just square both sides. So we square this side and we square that side. Okay, so here you have your exponent and your square root. 2 and 2 will cancel each other out. So you end up with negative 2x plus 4. But on this side, remember, you have two terms now that you're squaring. So when you have those two terms and you're squaring it, you use the FOIL method. So I'll do that right on the side. So if you have 3 minus the square root of 2x plus 5 squared, that is 3 minus the square root of 2x plus 5 times 3 minus the square root of 2x plus 5. And let me give myself a little more room. All right, so if we use the FOIL method, we have our first 3 times 3, which is 9. Our outer 3 times negative square root of 2x plus 5 minus 3 square root 2x plus 5. Our inner 3 minus times the negative 2x square root of 2x plus 5 square root of 2x plus 5 And our last, we have a negative and negative, so that will end up being a positive. Square root of 2x plus 5 squared. All right, so we can combine these two middle terms. Negative 3 and negative 3 is negative 6. So we have 9 minus 6 square root of 2x plus 5 plus square root of 2x plus 5 squared. Remember, the square and the square root cancels out. So that leaves you just with 2x plus 5. We could put parentheses around that, but you don't have to because that's a positive number and it would just distribute and they will both stay positive. Okay, so we can combine the 9 and the 5. So 9 plus 5 is 14. So you have 14 minus 6 square root of 2x plus 5 plus 2x. All right, so we can go ahead and replace that with this. So that's equal 14 minus 6 square root of 2x plus 5 plus 2x. All right, so now what do we want to do? We want to isolate the radical and square both sides again. Okay, remember I told you you have to isolate the radical twice? That's why you have to isolate it twice. Okay, so I'm going to add 6 times the square root of 2x plus 5 to both sides. So I'm just not going to write it down, but you have 6 square root of 2x plus 5. Because if I add it, then it would cancel out and become 0. So if you want, you can just go ahead and draw a little faint line through it to remind yourself that you already added to both sides, or you can actually add it. Either way, it's up to you. We can add 2x to both sides. So if you add 2x to both sides, 2x plus the 2x you just added is 4x. We add 4 to both sides. So we add, well, subtract 4 from both sides. So we have 10. So minus 4 is plus 10. All right, so now that we've done that, remember this 6 here is not a separate term because it's being multiplied. If you'd have had 6 plus 2x plus 5, then you'd have to isolate it. But because that 6 and that 2x are multiplied, you don't have to get rid of that 6. Okay, so that's just like, let me see if I can write out a quick example to make sure you get that. It's like if you have x plus 3. Those are two terms because they're separated by a plus sign or minus sign. Two terms. But if you just have 3x, there's no plus or minus sign separating those two. So this is just one term. That's just like this. This is just one term. All right, so now that we have the term isolated, we go ahead and we square both sides. Okay, so this square, because it's all one term, everything in that term is squared. So you have 6 squared times the square root of 2x plus 5 squared. So 6 squared will give us 36. And the square root of 2x plus 5 squared is just 2x plus 5. Okay, and that's equal to, well, I'm not going to do all the steps, but 4x plus 10 squared is 4x plus 10 times 4x plus 10. So if you use the FOIL method, you would get 16x squared plus 80x plus 100. Okay, so that's if you use FOIL. All right, so if we go ahead and distribute that 36 times 2x, we would get 72x, and 36 times 5 is 40. That would be... let me make sure. 36 times 5. 5 times 6 is 30. That's 180. All right, so we have our plus 180 equals 16x squared plus 80x plus 100. Okay, so if we subtract 72x, and if we subtract 180, that will leave us with, because that cancels out, 16x squared. 80 minus 72 is plus 8. And 100 minus 180 is minus 80, which equals 0. And we could use the A times C method on this, but that would get kind of messy. So the first thing we're going to do is divide each term by 8, because all of those are multiples of 8. So 16 divided by 8 is 2, so we have 2x squared. 8 divided by 8 is 1, so that's plus x. Negative 80 divided by 8 is 10, and 0 divided by 8 is just 0. Okay, so this is a little easier to work with than all of that big stuff up there. Okay, so now using the A times C method or quadratic formula, whichever one you like to, you can go ahead and factor this, and that would give us 2x plus 5 times x minus 2 equals 0. So that means that x equals negative 5 over 2, or x equals 2. And if you plug both of those into your original function, you can see that both are solutions. You plug them in. All right, so that is how you would solve it for 2 radicals. All right, so hopefully this made sense, and I will see you on the next video.